Okay, so this is our circuit for the prototype of our automated light project, where basically the idea is we have two distance sensors facing 90 degrees from each other to create an area in which any point in this field can be measured through these two distance sensors. And then based on the each distance of each sensor, it goes into the Arduino and it can communicate with the two servos here. And the way we get the light, which will be mounted on a rig of these two servos, is we have the first servo mounted how it is in the picture, and then the second servo turned sideways and put right on top of the first servo. That way we have motion in the X and Y direction, which, as you can see in the build here, it would look a little something like this. Since I'm in my dorm room, I don't have access to everything, so I just built a little model. This way the build can turn like this, and then on this arm it can also move like that, so it can point to any point in the field. And so back here, here we have the trig and echo pins connected to 12 and 11, and then on the second distance sensor, trig and echo to 9 and 8. And of course, the trig pin is connected to an analog pin. And then we just have our power and ground here. And this breadboard is just for some more organization. And then our signal wires for each servo is connected to two analog pins, 5 and 3. And then finally, looking at our code, we just have the setup of basically the distance sensors and the servos. And then we have, it's as written here, a function to measure distance using the distance sensor. And then this is just to calculate the servo angle. So basically in this code, the way it is I set it so every interval, basically every increase of 3 centimeters correlates to 10 degrees of increase of the angle. So I set it to 3 centimeters because that was sort of a good distance for this demonstration, but the real thing obviously will be a lot bigger, so the distances will be a lot bigger as well. And so continuing, we have void setup for the servos as well, and then just some serial print for the serial monitor, and then a delay at the end for stability. So then showing this thing actually working, since this build is not very strong, I tried doing it with both things together and it would just sort of fall apart because I'm in my dorm, so I don't have any access to all the tools. So I'll just show each servo independently. So starting with just the y-axis, it's connected to this distance sensor. So as you can see here, the closer you get to, if it was mounted like here, the closer you get to the servo, the more down it points. Sorry, my hand keeps shaking. And then as I get farther away, it stays at a higher angle. That way things in this direction can be pointed at by the light. And then I'm gonna try and get this to work. This is the one that doesn't work too well with this build. This is the X direction. Sorry. I'm gonna actually cover this one. Okay, hopefully that helps. I'm gonna try to edit this part out. Okay. So as I move closer to this, oh shoot. Okay, it's kind of hard to tell here because there's so much going on. Okay, there we go. So when I'm closer, when I'm closer, it basically moves to the left because when it's all set up, it would be lined up properly. But basically, as you're moving close to the sensor, it moves to the left, and then away, it moves to the right. And yeah, basically this would be pointing in here but just for the sake of the demonstration, I just have it here. But yeah, that's pretty much it.